Please stop me and ask. We don't have to wait till the end of the presentation. And other than that, yeah, I think we can move forward. So good morning, everyone. My name is Shankar. I'm here on behalf of StatWorks. And today our presentation or my presentation will be about Power BI and how it can be used to conduct what is known as data cleansing and data modeling for the purpose of analytics. So for whoever who is from the analytical background, whether you are a data analyst, you are a data engineer, you're a data scientist, or you're doing some form of visualization, doesn't matter, using Tableau, Spotfire, even Excel, today's session will help you gain a better understanding on how Power BI is used to prepare data and also model the data for an analytical use case. Okay, so what I will do first is I will just go over what StatWorks is about, and then just a brief introduction on Power BI and what are the components of an analytics lifecycle. And then I'll go into a short demo of Power BI on how easy it is to use Power BI to clean data and also to model the data in a logical manner. Okay, so let's begin. So StatWorks, for those of you who do not know, we are basically a big data consulting company. We do a lot of big data project implementation, as well as consulting and even training services for certain technologies like Power BI and Tableau and Spotfire. And also we specialize in data science methods, things like machine learning, artificial intelligence, depending on the type of use case the customer needs and what is the kind of business insight they want to gain. So as I mentioned, we provide analytical solutions, and also we have our own data science platform known as Perceptron 360. I will talk a little bit of this maybe towards the end. It's basically our one-stop platform where we provide multiple solutions depending on what are your demands in terms of data management, data organization, data visualization, and even data science. Okay. So to help us implement all these solutions, these are a list of our partners. When we take part in any form of big data implementation, we have, for example, TIBCO, which is a data management expert. They provide multiple solutions, which includes also TIBCO Spotfire, which is a BI tool similar to Power BI and Tableau as well. Then we have Esri, which is a GIS expert. So we work together with them to implement advanced mapping solutions. DataWalk is a very advanced technology used for link analysis for fraud crime in banks, even immigration to detect criminal activities. So they specialize in that kind of analysis. And also technological players like IBM, for those of you who already know. Now, when we say we are a big data consulting company, we handle a lot of government projects. For those of you who do not know, right now, the Malaysian government is looking to implement a lot of big data transformation. What we mean by that is every department, for example, Jabatan Alam Sekitar or LHDN or even Bank Negara, they need to consolidate their data across departments and then use this new form data to conduct an analytics works depending on the use case they are trying to solve. Let it be business optimization, workflow optimization, improve revenue, detect losses in the business. So all these kind of use cases, whenever the business determines a problem, they will need to first gather the data from all the multiple sub-departments within the agency and even external data, things like web scraping, Facebook, social media, and things like that. They have to store it in a centralized repo. And then from there, we will decide what kind of analysis we will do. Let it be visualization, making charts and graphs, modeling, predictive modeling, and many others as well. So we handle both local, and we also had a few international projects, as you can see from here. And as well, locally, besides government players, it's also MNCs as well, like Grab, and certain banks as well. All right. So that is a brief introduction about StatWorks. Does anyone have any question in terms of our service offerings and whatnot? I will talk about this towards the end as well in terms of what we can do for Power BI. For now, is everyone okay? Let me just see the, sorry about that. Everyone's okay, yeah? All right. So now, looking at Power BI, I'm sure even I myself, many years ago, when I heard this, when everyone thinks Power BI, we think, oh, okay, charts, graphs, maps, making very beautiful interactive charts, and we just straight away go, okay, Power BI, Tableau, ClickSense, these are all the same thing. Their main function is just to make charts. But does anyone know what does BI stand for in Power BI? BI basically stands for business intelligence. And what business intelligence is basically a set of processes and technologies which are used to convert raw data or any form of data that belongs within a company or outside a company to help gain some insights and information so that the company itself can make more informed decisions about its business, whether it's to improve its business or to even expand its business. All this kind of requirement is what business intelligence looks to solve. So if you can see from the picture on the right side here, this is basically what an analytics pipeline or life cycle looks like. You have your external data sources, and then you have what is known as ETL. ETL simply stands for extract, transform, and load. Basically, it means the extraction of the data, the cleaning of the data, which is transformation, and then the loading of a data into a centralized repo, or repository, which we call as a data warehouse, and sometimes a data lake, depending on what kind of data you're storing. From there, this data is fed to many different purposes. One of it is business intelligence. And then you have data science things like machine learning models and predictions and other form of advanced analytics. So this is what business intelligence is all about. And as to why companies need business intelligence is basically overall is to remain competitive in this current world, to better understand your customers, to boost your operations, and improve your efficiency, and many more. I just listed out a few here. So why am I telling you this? When we look at the life cycle, the most important thing, like everyone only sees the bar charts and the line charts and the advanced graphs at the end, and which is what we think is the important portion or what these tools are used for. But actually, the hardest thing to do when we talk about BI and the hardest thing to implement and to get right is actually everything before the graphs and charts. In this case, is the data cleaning and the data warehousing, as we call it. So when I say data warehousing, what do I mean by data warehousing? Basically, it means right now, if a business, for example, a company wants to improve its sales performance or its overall revenue, I will need data from multiple areas of the business. I will need data from my production. I will need data from my sales. I will need data from my logistics. I will need data from my vendors, from my procurement side. So all these data first has to be collected, has to be sorted and stored in a data warehouse. When I say warehouse, what is a data warehouse? Basically, just like any other warehouse, if you have been to a warehouse or what we call as gudang in BM, a warehouse basically contains a whole lot of various items that has to be stored in a very organized manner, because when I need the item, I need to pull it out quickly and smoothly. But at the same time, I need to store a lot of different types of items, and I need to store a large volume of those items in a warehouse. So similarly, a data warehouse works the same way. I'm taking various types of data, and I'm taking a lot of it. It can go back many, many years, because we like to study trends and do some temporal analysis. And then I have to organize them within the warehouse and also make sure the relationships between each data source is tied correctly. They are not sitting as standalone compared to the the typical how typically a business operates. Procurement sits on their own, sales sits on their own, um, um, production sits on their own, and so forth. So when we do data warehousing, we are consolidating this data in an organized manner. And this is what we call as online analytical processing, or better known as OLAP. When we talk about the conventional storage, whereby each of the business functions function on their own as separate entities, we call that as online transactional processing. When we say transactional processing, or known as OLTP, transactional means any form of data storage related to day-to-day business. That means the monthly or daily operations of the business is stored in this individual databases. But when you do analytics, you need to gather all this data together, and because of that, the entire properties or the concept of storage is very different compared to OLTP. This is OLAP, OLAP, and this is OLTP. I will explain later why is this all important and how does it relate to Power BI. For now, just bear with me, yeah. So as I spoke earlier, the difference between OLTP and OLAP or OLAP, in terms of data sizes, when we go back here, individual storages compared to a consolidated storage. So of course, OLAP is going to have a much bigger amount of volume of data to deal with. And then when we model the businesses, the database for each individual business, it is designed to cater for the business alone. That means for procurement, all the workflows is designed for procurement only. Data is stored so that people in procurement only know how to read and access it. But when you do analytical study, you need to model your data based on your use case, whether is it improving sales, whether is it optimizing production, whether is it reducing losses and things like that, okay? And then when we talk about the presentation of data, I will show you a picture later. But when we look at conventional storage, in every business entity, all the data is only related to that entity itself. That means procurement will only talk about procurement data. So it's very 2D in a sense. All the table has only data related to itself and nothing else. Whereas for OLAP, I'll show you a picture later, it's more of a 3D representation whereby we can view a given data from multiple angles. A simple example of this is if I'm studying customer, I can look at a customer's revenue, revenue to the company. That means I will pull out all the sales data related. I can look at the customer's location on the map to improve my logistics. So I need to pull out data from my logistics side. I can look at my customer's purchase demand. So I can optimize my production. So I have to pull out production data, but all in relation to the same single customer. This is what we mean by multiple dimensions for a single entity. And finally, when we look at data timeline and data sources, data timeline, as I mentioned, OLTP is only interested in the day-to-day operations of the business. As long all the records come in daily or monthly, it'll be stored for a short duration and then move to long-term storage. Whereas for data warehouse, we are always interested in the full length of the data, because only then we can do some effective analysis. And as for the data source itself, it's quite obvious from here. In OLTP, it is all individual standalone, or what we call as siloed data storage, but a data warehouse consolidates all this data. So now that I've spoken a lot on data warehousing and also the different types of processing that is done, here is an example of a 3D representation. As I mentioned, we have, for example, a bunch of products. We have product color and the year. So if I want to do analysis of product by year, I can pick out the table, pick out this 2D representation. If I want to do product by color, I can slice the data in any way I'd like. Whereas in your conventional OLTP method, this is a standalone in one database, and a product against color is a standalone in another database, and so forth. So this is what we call as data modeling. Later, I will show how Power BI enables this creation to allow OLAP form of analysis to be conducted. So how does Power BI fit into all this? As I mentioned earlier, Power BI, people usually view it as just making charts. and whatever the data underneath has to be prepared somewhere else and then fed into Power BI to make those charts. But actually, some people or most people may not realize Power BI over the recent years has come with its own built-in capabilities to do data cleaning as well as to do data modeling itself. And one of the beauties of Power BI, I feel, because I'm a user of Tableau, Power BI, and Spotfire, depending on our project needs, I've actually tried all this software. And one of the key features I found about Power BI is this data cleansing part, because Tableau allows you to do it as well, but you need to install a separate Tableau software known as Tableau Data Prep. So the software is separate from the Tableau that is used to make graph. They call that Tableau Desktop, and then you have Tableau Data Prep. So these two separate softwares have to be installed, and then they have to be linked together. And in a sense, they still operate separately. And if we look at Spotfire, Spotfire does not have a very strong data modeling and data cleansing capabilities. So usually we rely on another software to install and do all this data cleansing. So that's why for today's session, what I'll be demoing to everyone is Power BI's capability to do data cleansing. Because as far as doing the charts, from what I've seen, Tableau, Power BI, Spotfire, yes, very, very powerful charts. But in a way, if you know one, the others are very similar with small significant difference between them. Maybe Spotfire has better mapping, but Power BI has better automation. Tableau has a better background, things like that. But when you talk about data cleansing, this is one of the very glaring difference I found between Power BI and the others, and which I felt is very important to share today, simply because at the heart of any form of analytics is the data preparation and the data modeling. And one good thing about Power BI, or sorry, another good thing, because it is a Microsoft native application, Microsoft is very smart in that sense. They have actually set up Power BI to look very familiar to those who are heavy Excel users. So later when I show you the environment for Power BI, those of you who are heavy on the Excel part, you may find this environment quite friendly and easy to use. So that is actually one of the strong things about Power BI, and another differentiator. For those who are Microsoft lovers, this actually will seem very familiar and also very comfortable for you to use. So before I go into the demo, does anybody have any questions? Just stop sharing for a while. Anyone has any questions? Or is everyone clear? All clear? Just give me a reaction or a message or something.
Clear, clear.
Clear, yeah? Okay. Just one moment. Let me open up Power BI. Okay, can everyone see the Power BI environment? Okay, can, yeah? All right. So when you first open up Power BI, this is what you will be, this is what you are greeted with, basically, this front page, okay? So in order to master Power BI, there's 3 sections that one needs to know, in order to be very good in Power BI. Number 1, the 3 sections are actually over here. This is your visualization pane, okay? So this refers to building your charts. You can see you have all your charts and everything here, and you can just build your chart on this page. Over here is your data page, whereby you can create new columns. You can modify, add advanced calculations to the existing tables that are there already. And the last one is your data modeling section. This is what we'll be talking about over here and also on the data cleansing part. So later at the end, when I'm done with the data cleaning, you will be able to see how we form logical relationships, and tie the tables together to form what we call as reference tables to your main fact table. Okay, so that means when you have some form of, say, sales data, for every component of sales data, let's say you have customer name, if I pull out the customer name, I want to have a separate table that describes everything about this customer. I do not want it on the same table as their sales. So for example, I say customer A, it must be tied to another table that describes where this customer is, when the customer started, what region is this customer located in, and things like that. And then if I look probably at another column, say whereby we can talk about, say, a user. So if I select a given user, I want to have an underlying table that explains everything about a user, maybe his gender, his age, his monthly expenses. So all this, we do not want it to be on just one table. Conventionally, that's what will happen. If I need to know more data, I will just add more columns to a single table and make that table so massive that your computer might just hang after a while. So I will show you how we build all these separate tables and we link them up together. Okay, so we come to the front page first. Right now, I have loaded in 3 data sets you can see here. All right. So we have basically these 3 data sets. There are 2 CSVs and an Excel talking about population of a country, of countries. Yeah, population of countries. So we will now go to over here, transform data, and I want to do some data cleansing. Okay, we're going to work very quickly on how fast we can cleanse data using Power BI. So as you can see here, I got population 2010 to 2019, 2020 to 2029. And this one actually represents population from 2030 to 2040. So what I'm going to do, I'm going to quickly rename it. Population from 2030 to 2040. Okay. And one thing good about Power BI, everything you do in your cleaning stage, whenever you're cleaning, is recorded on the side here. So you can always backtrack on what you have done. Okay, you can always backtrack. In the case, if I don't want, I can just cancel it and the names go missing. Okay, so now 1 second. Yeah, all right, navigation. Let me just delete this source. So basically, if I want to load in data, I just come to new source. I can select what type of data I want to load in. Power BI has connectors to just about every form of data sources. These are just for only files that are stored on your computer and even SQL databases. So I want an Excel workbook and I will bring this in. Okay. Load this in. All right. Just rename this. Okay. So now let's look at some data cleansing first. We got 3 tables. We're going to start cleaning them. So one thing Power BI does very well, if any user, usually when we go into a data cleaning exercise, the user actually has to know beforehand what is wrong with the data, which is very hard because they actually have to first study themselves and use Excel or whatever to know that, okay, this column has some missing values, this column has some dirty numbers and things like that. But in Power BI, you have under their view section where you can view column quality. So you can see from here, column 3 has some issues. You got empty values, there are missing values, and even here also has missing values and so forth. So what we're going to do first, right now, when we look at this table, the loading of the data seems to have an issue. This is supposed to be your header, but we have a weird row over here that shows some unknown data. We want to throw this away. So Power BI is a very simple thing. You can just say remove rows and say remove top row. So I just take away the first row, done. First row is done. Now I need this to be my header. I do not want it to be a row on its own. It has to come up here. I don't want to see column 1, 2, 3. So again, a simple button over here, use first row as header. And just like that, it's become the header already. Now we look at the second table. It has the same issue as well. So I just have to do use first row as header. Done. And the third one is perfect. Okay. So now we want to know where to start. For that, we will use this column quality check. So from here, we can see, all right, there is some missing values in the time section. So for those who are Excel users, when you use the data filter option right here, you can actually see, the design is the same as Excel. And in fact, later on, when you go to more advanced concepts, Power BI actually uses Power Query to sort through its data and to do calculation. And Power Query is also the standard, you can say, extension of Excel itself. So when I go to load more, I want to throw away null. Yep, I want to throw away null values. Say OK. And as soon as you're done, it auto adjusts to say, OK, done. It's been cleansed already. So now we have all our rows that are OK. And now we look at the next item. If we look at this age group over here, is everyone okay? I think somebody's mic is on. If you have a question, please feel free to ask. All okay, yeah? Okay. Now that we have already fixed the empty, thrown away the missing values, okay, first things first, I'm going to join these three tables together because their columns are all the same. So instead of cleaning the table one by one, we are going to merge all of them first. So how do we do that? We just come to merge queries over here. And I'll say merge as new because I want to create a new table. So I'll say sorry, not merge. We have to append. We want to add rows. We want to add these as rows. Okay, sorry. Must go to append. Append as new. Okay, 3 or more table. Basically, we are appending more than 2 tables. So I have the 2010 to 19. I want to add 2020 to 29 and 2030 to 2040. And just like that, a new table is created and it's all appended. You can see no new columns were added. That means the joining is, the appending is successful. So now I'll first rename this quickly. Population 2010 to 2040. Okay. Sorry, can everyone hear me? Was I, did everyone hear what I've said so far? All okay, yeah? Can I? All right. All right, so now we have already merged the 3 tables together and we have a new table called as the 2010 to 2040. We have combined from 2010 to 2040. So now let's do some simple data cleaning. Over here, we have the age group column, which is basically showing segregation of ages from 0 to 4, 5 to 6 and whatnot. If we drop down over here, we can see that there's a segregation. But clearly, when we loaded the data, there's a misreading of the data. So some of the columns, instead of 5 to 9, it's trying to treat it like a date and going 5 to September. So I need to correct this to 5 to 9, and even this, I need to change it to 10 to 14. So usually in other forms of ETL tool, we have to write some script to make these amendments. But if you're an Excel user, and even here, what we just have to do first, I just take out all these wrong rows. So I have it here. I just have to right click, replace value, and say replace with 5 to 9. Done. But now the thing is, because I initially filtered the row, all I have now is 5 to 9. So how to bring back everything else? You just throw away the filter step. Done. So as you can see now, we have fixed the 5 to 9 and we brought back all the data. So same thing, I just quickly repeat for October 14. I filter first, right click, replace, and say I want 10 to 14. Okay, all right. Now let's just check. So let me remove this filter first. Remove this. Okay. That is done. You see over here. Okay, there is still a bit of null values and no data. Okay, so we have removed the null values and no data. We have also fixed these errors over here. Okay. What is the next thing we can do? Now, I want to remove some columns that I find unnecessary. For example, I want to remove this, and also the sum of population, because I already have male population, female population. I don't need the sum. I can calculate it later. So how do we do that? Either you can do one by one, where you select, you right click, and you remove, or you can hold control and select multiple. All right. So I will remove column. Okay. Okay. So we have done removing the column. Now, for those of you who may know, in analytics or for dashboards, our dashboards usually like long and slim tables. That means we don't like to deal with a lot of columns. I rather deal with 1,000,000 rows than deal with 100 columns. This is just an optimization step to improve your processing time. Okay, it's more on a technical side. But because of this reason, it gives us the excuse to use this function, which is called pivoting. So Excel users, of course, you will know what pivoting is. I want to pivot, or sorry, in this case, I want to unpivot these two columns. Okay. So how do we do that? We just select both the columns. You can right click and unpivot. Also, the pivoting functions are all here. If you want to come and select, it's over here as well. Okay. But for those who are want some comfort, you can always just right click here and do it. So once you unpivot, we need to rename these columns. So now what we have is basically all your gender and you have your population. So I'll say gender and here will be population. Okay. So just like that, we have replaced some null values. We have done some pivoting. We have cleaned up. We have detected and cleaned up any form of missing data and whatnot. And now very quickly, I want to rename the columns because later when I'm doing joining, it's going to make my life easy. So this one, I will put it as country code. And then here I'll say this is country. Note as I'm changing each column, all of it is being tracked. Yeah, all of it is being tracked. So because now I'm changing all the names at once, it will all be stored under one action. All right, it will all be stored under one action. And then here we have gender and population. Okay, now we have done that already. Note that whatever we have done so far, it is not being applied yet. That means whatever you're seeing now is stored in memory and we haven't actually applied it to the data set itself. This is what is like a virtual view you're seeing now. We haven't actually in real life amended the data. Okay. So in order to do that, just another thing before I apply the changes. Over here is your data types. Data types is a very important thing that we need to understand. If you set your data type wrongly, it's going to affect a lot of your charts and your calculations. So now by default for columns that Power BI's automated detection cannot help, they will give it this ABC123, which is basically it's saying there is maybe part text and part numbers in it. So for country code, although these are numbers, but they are codes. So I don't really need to represent them as numbers because I'm not going to add up country codes. I'm not going to do any division on the country code itself. So from here, I can just put it as text, which is ABC. Country is also text. Year in this case, because for now it's just the year, I'm not going to deal with it in a date time format. I can just leave it as a whole number for now. For more advanced calculation, you may have to set this as date time if you have the full date and time itself. So these categorical variables are all what we call as string. So we can leave it as text. Now this doesn't really look nice. I want to rename this to male and female. I don't need this pop male and pop female. So what I do, same thing as replacement. I right click male, I replace, and I just say give it male. Okay, done. And now same thing for female. I will replace values and give it female. Done. Okay. So now I have made sure the data types are correct. I have cleaned up. And population over here, this is actual numbers. So right now I will say, as you can see, there are decimal numbers here. So I can say set as decimal. And if I want to do some rounding, okay, because you can see the decimal places are running quite a bit, just come to transform. And because note that because you set it to numbers, if I was to change this to text, okay, if I change this to text, you see, I cannot select any form of mathematical function because it's detected as a text type. So I must put it as a decimal or a number. And then now you can see, okay, I want to do rounding. I want to round to 2 decimal places. Okay, done. So now all is done. I have to apply these changes to the data set itself. So when I come here, I'll first hit apply. So it will start updating everything. Now it's actually implementing the changes. Okay, so as you can see now, there is some error detected. So we will look at how to solve these errors. Okay, so we come to view errors. So one thing about Power BI, when you view the errors, this page may just keep on loading for some reason. So what we have to do to speed it up, just close, and then we go back in. It is some, I believe it's some bug within Power BI from what I have checked with them. So if we come to over here, it shows you which exact row is throwing an issue. So it says under population, there is something here, something wrong over here. So if we see the error, so in this row, this exact row, they don't have a number in there. It has what is known as a text. Basically, instead of having a number, you have written over here error underscore 6.246. So I need to change this to a number. So just for this webinar's sake, what I will do is I will select this number. Okay. I'll come to this table over here, and under this column for your replace, okay, you have replace values, or even if I come to transformation, I can replace errors. Okay, so I know what is that error already, and I want to give it a number. Let's just say I want to give it 6.2.6.23. Say okay. Okay, then let me see what is the error in this one. Okay. Okay, yeah, sure. So now that I've done that, come to home, and we'll see whether we solve that one error first. Yeah. So as you can see, now I've applied the changes with no error has happened. So just like that, it actually has a function to replace errors. I just come here. Again, I'll show you. I'm sorry about this. Yeah. So we can replace errors. So that's it. We have now fully cleaned the table. We have prepared it according, removed all the issues, and applied the changes to the table itself. Now, when I talk about, we haven't come to data modeling yet. We are only so far talking about ETL or data cleansing. We have just cleaned the table. Now, when I want to do analysis, let's say I'm today looking at the population of population data. I do not want to have my main data, or what we call as my fact table, a fact table, to have a lot of unnecessary other data, simply because when you do analysis, the heavier your table is, the more, the longer it will take to run analysis, the more confusing it becomes for the user. So I want to create one table where I have my population, and everything else must be indexed. That means it must just have either 1, 0 or 1, 2, 3, 4, 5, 6, and only have codes, like, for example, this country code over here. So this is what we call as creating dimensional tables, or creating reference tables. For example, I can create one dimensional table to hold data about country. I can create another dimensional table to hold something about gender. For now, we have male and female. If we have more down the road, you must have one table to describe all the gender. It cannot sit in your main analysis table. And same for age group, we can have a different table to give more details about the age group. So what I'm going to do now, I'm going to start with this country code. I want to what we call this, create a dimensional table for countries. So first, let me just throw away this error. There's no longer an error, so I delete it. All right, I'm going to create a new group first. Whatever we have cleaned, I'm going to say this is my source group. Okay. So I want to move everything into my source group first. We're no longer touching this. This is source group. And then I'm going to create a duplicate of this latest table that we cleaned. So I'll say duplicate, and I'll move this to this table. And I'll rename this. For now, we're going to start with what we call as region or country. So I'm going to say this is my dimensional for region. dim region. Okay, dim region. Okay, so for dim region, we only going to create all the data related to region itself. So what I'm going to do, I'm going to throw away all the other columns that are not needed first, which is year up till population. I don't need this. All right. So now we have country code and country. All right. This table is going to be used as a reference. That means in this table, all your country code should be unique. So what I'm going to do is I'm going to first remove all the duplicates. So again, just right click, remove duplicates. So in other, again, please note in other ETL tools, it may not be as easy to do it. Usually we have to script or write a code to say, go in here. If a duplicate is found, do something. If a duplicate is not found, check for this condition and things like that. Okay. So now I've removed the duplicates. I'm going to import in another table to give more explanation about the regions. All right. So I'm going to go to home, say new source, and this time it's going to be a CSV. And I'm going to take in codes. So when you import a CSV, the Power BI will ask you, how do you want to separate this data? So usually if you say comma separated, which is a CSV, you can see it doesn't give you what you want. So sometimes you will try, because maybe when whoever is writing the CSV, they use the spacing as tab. So from here you can see, yeah, it is a tab separated CSV file. Oh, sorry, text file rather, tab separated text file. So I'm going to import this data in. Okay. When we look at this codes table, here is actually describing the regions. Okay, we have Asia, Europe, Antarctica, Africa, and then the country code and also the country name. For now, we do not need these two columns, so I will delete them. And now let me just rename this to make it easy for everyone. Region code. All right. This is also country code. Note that I am pay attention that I'm using the same column names wherever in other tables you see got country code. I try to follow the same convention so that is easy. And here is country, but actually I do not need. One second, yeah. Let me just see. Do I need it? Not. Do I need it? Sorry. Region, country code. Yeah. Okay. So. Yeah, I don't need this column as well. Remove. So now what I want to do, now that I've imported these codes in, I want to actually give the name for each of this code. Because as I told you, it's Asia, Europe, and things like that. So first things first, again, I remove the duplicates. Okay. So I remove duplicates. And now, how do I add another column here? Or how do I get this column to come out? There are many ways to do it. I'm just going to show you one way. First, we copy this table. Okay, copy it. Click over here, copy. We go to enter new data, and then we just paste. Okay, so we can right click and paste, or I can use Control V. All right. So we got region, country code, region code, country code, and now I'm going to put in the region name. So I just named it as region. So we got Asia, Europe, Antarctica, Africa, Oceania, North America. Oh, sorry, there's a null value. One moment, yeah, there's a null value. Apologies, I need to remove that null value. Yeah, let me undo the duplicates and first remove the null values. Yeah, okay, null and blank. So we have removed the null values, and now I go back and do the same thing again. Remove duplicates. Okay, copy the entire table. Come to create a new data, and I just paste it. And here, same thing. I just type region. Okay, so we have Asia, Europe, Antarctica, Africa, Oceania, North America, and South. So this is what we call as creating some new details to be added in. Okay, we are basically creating what we call as feature engineering, creating new data from existing data. And I hit OK. All right. So now the new table is created, and I'm going to say this as region details for now. All right. Now, this is your codes table. I need to put the region table into here first. I need to append. I need this detail to come into the codes table. So for those who are familiar with merging, or what we call as joining, all right. Just now we appended. Appended means adding rows. We use merge to add columns. Okay. So I'll say merge queries. This is your codes table. They'll ask you which table you want to merge with. I say region details. And what I'm going to do is I'm going to do an inner join on region code itself. Okay. So one moment. Yeah, I have to first undo these duplicates because this contains all your countries. So I need to map each country to their region. So I remove the duplicates, and now these are all your country codes. So I'm going to now map it. Okay. Say merge queries, region details, and I will map based on the region code. And I'll say, give me a inner join. So immediately, inner join meaning because we want a one-to-one mapping, you can see there's a full perfect match across the board. So we hit OK. And right now, as soon as you merge, Power BI is smart. It doesn't straight away fill up all the columns. It gives you the choice to choose. So from here, you can click this and say, all right, just give me region. This is the column I only wanted to add. And like that, you have your region added in. So now I rename this to region. Okay, done. So now we have already created the base table, which we now need to join to my dimensional table. I need to include this code and also the region because we don't have, you see, we don't have the region code and the actual region name. Let me just remove this column quality. We don't need to see column quality anymore because our data is clean. So now I need to merge this dim region onto the codes itself. I want to add the column. So it's a double merge, this on this and then this on this. So I say merge. This time is dim region onto codes. And I say do a left outer join. So I'll say merge on country code. So as you can see now, immediately they throw an error. Select columns of the same type. This is a very important notice people may overlook. You will see in this table, the country code is a text data, but in codes, the country code is a number data. So we just change this to text. And now we try again. Tables will never merge if the data type is not the same. It's a fail-safe built in, okay? Because if they allow it in the as you go down the road to do analysis, it's going to cause a lot of breaks in the chain. So now we merge with code and I say do a left outer join. So I need to make sure all the rows in here finds at least one matching over here. So I'll say country code and country code. So as you can see, it's saying only 193 has matched. That means there is 6 rows in here that couldn't find a match from the reference table. So this is a part of analytics which is very important when you're setting up. It's called data quality check. This reference table, this is your so-called library table. Your library table must contain all your data when you're building it. So now itself, you can see it is 6 rows cannot find a match. That means there are 6 countries here that cannot match, that we do not know what is the region code and the region for it. We do not know. So how do we find the 6? We go for what is known as an NT join. I won't go into details of the different types of joins, but this NT join is what will tell you or show you what did not match. So we can see from here, these two did not match. I mean, these rows, these country codes were not found in the codes table. So what I want to do is I want to first add this into my codes. I want to update my table of these new data that are inside the dim region. So what I do is I will first remove this. Okay, remove this. Again, I copy this table. All right, I enter data and I paste it. And I know, that means I know what are all the regions for this. So I need to update it. I'll say region code. or I'll say the region first. So this one falls under Oceania. This is just for argument's sake, yeah. Oceania. Maybe this one I'll give it Europe. Sorry, my geography is not so good. Okay, Oceania. Here is this is Asia, and this is Asia, for example. And let's say this is Africa. Okay, and now I need the region code for it as well. Region code. Be sure these columns, the names are the same, because as you're appending it later, it may throw an error. Okay, so I'll say EU, OC, AF, and AS. Okay, done. So the new table is created, and I say this is added countries. Okay, now I need to first update this codes table. All right, I need to append these rows into the codes table. So first things first, make sure that your columns are in line. So over here we have region code, country code, and region. What do we have here? So over here we have country code, region code. So we don't actually need the country name because the code explains it itself. So I remove this. So now we have region code, country code, and here we have region code, country code. Okay. So now let's do appending. Let's append it. So I want to append just two tables. I want to append codes onto added countries, and I append. Okay. As soon as I append, let's see over here. One second, yeah. Codes. Okay, so note one thing. As soon as I have appended this in your dimensional table should automatically disappear because I've already updated the table. But now it is stuck. Why is it stuck? This one is where we need to be careful. As you can see, no error was thrown. In my added countries, the country code was maintained as numbers, whereas everywhere else, it is supposed to be text. So as you can see, an error has happened here already. From text, it has changed to text and numbers. So I will come here, I will change this to text. And then over here, you can see it automatically updated. And here, it disappeared. That means it is now showing, if I go back to the merge queries and I say, I open up the merge queries and I say, give me a left join, I should get a perfect match. As you can see, because we have added inside this codes table, we have added just now the missing rows. So now everybody matches. Okay. So over here, what do I want from here now? I want my region and region code only. Are you sure you want to insert a step? Okay. So, oh, okay. Yeah. Sorry, I have to do it from here. Yeah. So over here, okay. I will remove this first. Yeah. And then I do. Yeah. So now here, I only want my region and region code. So like that, we have developed a dimensional table describing everything about the country. And this will be used to join to your main fact table later. So now when I have country code here, I can throw this country column away because whenever a user wants to view any details about a country, it will come to the underlying region table. Okay. So I will move these source tables away first. Okay. So we have done one of this. Now, let's try to do quickly one for gender. So I create another duplicate. I'll create a duplicate here of the original table here. I'll create a duplicate and I'll bring it into over here. And I'll say this as dim gender. Okay. For gender, we don't need all the columns. We only need the gender column. So I will say right click. You have the option to remove other columns. So I quickly remove just like that. And now what I want to do is first remove the duplicates because this is a reference table. We only need unique values. So I remove duplicates very quickly. And now I want to encode this. I want it to be in like code 1, 2 or 0, 1. So all you have to do is come to add column and apply an indexing and say from 1. So now we have gender code done. So now you have your dimensional gender table. We do a last one, which is talking about age group. So once again, I will duplicate this table. All right, move it into here and I'll say dim age. All right, so this one is quite interesting. This is the one I can show a bit more features. Again, we're talking about age, so I only need the age group. So again, I right click, remove other columns. All right, so now let's say now we got all these different age groups. We have okay, we have 0 to 4, 5 to 9, 50 to 54, and then 100. Maybe I want to simplify this. I want to put them into categories, whereby 0 to something is children, and then 10 to 14 is teenagers, and above is adults, and maybe last is seniors and things like that. So what I can do is, there's something known as create under add column. I want to create a conditional column. Okay, but before that, before I do this, right now I cannot do any computation on this because it's a string. It's a categorical value 0 to 4 and then so forth. So what I want to do is I want to take out the max value over here. So, and then use the max, a standalone value, as a reference. So when I say add column, what I will do is I will extract. All right, so Excel users, again, you may be familiar with this. I want to extract the text after the delimiter. Delimiter is this dash here. Dash is a type of delimiter. So I'll say extract after delimiter. And they'll ask you, what is your delimiter? Because delimiters, you got semicolon, you got commas, you got space. So in this case, I want the dash. Okay. And now I have just the digits. So you can see 4, 14, 9, and whatnot. So again, I will change this first to numbers because I'm going to run some computation on it. Data type change to numbers. And now I can do a conditional column, whereby if your age is between 4 and below or 5 and below, I can do some conditioning and maybe create a group for them. So I say conditional column. And now Power BI is kind enough to have this built-in things for you. 1 second, let me just rename this column. Max age. I'll give this as your max age. Okay. So now I go conditional column. So it's saying now first, what do you want this column to be? Let's say this is age category. Okay, age category. And now we go column name. So from here, you got your age group, or your new one I created, max age. Let's say if max age is less than or equal to 4, note that if you didn't change your data type here, you will not be able to access the data because it will view it as a text. So if max age is less than equal to 4, I want this to be put as baby, for example. Okay, let's add more conditions. Okay, I'll add a few more. Now, if max age is less than equals to, let's say 14, give it child. And the same thing, less than equals to, say, 24, give it teenager. And if the max age is less than equals to 34, give it adult, young adult. Young adult. And then we have max age is less than equals to 64. Give us adult. And all those who are like 100 plus, we'll give it senior. Above 64 and above, we give it. So the else statement is for everything that doesn't fall into this category, label it as senior. And your new column name is called age category. Done. So like that, as you see, if I load more, we have our labeling here all done. Okay. Now, similar to the others, I want to index them because later in my main fact table, I want it to be fully encoded. I do not want any text of any kind. So same, I'll index column from 1. Just like that, I got age code. So now we have indexed the categories. And by the way, I need to first remove, because this is a dimensional table. So I will remove duplicates. Okay. We only want it to be fully on the, what we call this, unique values only. So as you can see here, there is an error. If anyone wants to know what happened here with the error, It's simply because initially when I say extract from delimiter, this one didn't have a delimiter of its own, right? So what I need to do now, let me see if I can do it here itself. If I change this to -100, will it be able to run the script? Okay, then yeah, so I first have to change this. One moment. Sorry about that. 1 second, yeah. Okay, edit conditional column. Okay. All right. Sorry for the delays here. Just give me a moment. We're almost done already. Almost done. I remove the duplicates. Okay. Add column. Extract. After delete. So first I change this. Okay. Then I extract delimiter. This is the delimiter. Okay, and then max age. So sorry about that. Yeah. Conditional column. I just do this very quickly. Numbers. Okay. Additional column, max age, and equal to 4. Child. For now, I just make this quick to avoid wasting time. I'll say everybody else is adult. Okay, just for argument's sake, everybody else adult. I won't add any more conditions. Okay, done. So now when I do it, so we only have 2 categories here, child or adult. I'll do the indexing from 1. So you'll only get 1 and 2, basically. Yeah, sorry, you'll get you will still follow an indexing, but they are all the same. So later when you do as I've done earlier, child, senior, teenager, so each of these numbers will represent a different category. Now, just for argument's sake, and the interest of time, I just leave it as only 2 options. Okay, and here I will put it as age code. Okay, done. So now we have created all our reference tables. Okay, and we have our main fact table. So I'll just create one quick duplicate, move this here, and I'll say fact table. So now I want everything to be fully encoded. So I can first throw away country because we have the country code already. So I'll say remove. The year is maintained. Age group. So now, first things first, I want to do merging. So one moment. More to change this. Okay. All right. So now when I merge, I want to join the fact table with my age, dim age table. I will merge it on these 2. Okay. So you can see it's a perfect match. Once it's merged done, I only want the age code out. Show me age code because I'm simplifying the table now. Okay. Age code is out, so I can delete this one. Same thing for gender. I'm going to do another merge. Merge queries on the dim age gender table. And the same thing, I'm going to merge gender on gender. Okay. Say okay. And now give me just the gender code only. And now I remove this. So as you can see, what I have done now, I have cleaned up the whole thing. You have a fully encoded table with only numbers, okay? And you are basically ready for your analysis. This is gender code. This is age code, okay? Now I apply the changes quickly. All right. All right, it's done. Close. So when I come now, as you have seen, I've created all the links. When I come here, you will now see that Power BI is smart enough to detect the tables that are formed. Okay, so basically what Power BI has done, it has linked up all your work that you have initially prepared. Okay, so once, if you have done it correctly, you will see these links, and anytime you need to amend or adjust, sorry, I have to really adjust this the relationships for it. Just give me a moment here. So, no. Okay. Yep. So now you have your main fact table, your dim gender table, and your dim region table. Okay. So from here, you can see I want to connect country code to here to show that there's a relationship, but it will give a warning. It's saying that in your region, there's a lot of duplicates happening. Please check if this is the case or not. If not, it will form the join for you either way. But this is a warning. You shouldn't have this kind of thing happening when you do your actual join, unless your analysis actually demands you to have this is what we call a many-to-many connection. So basically, what I have shown you today, how easy it is to do data cleaning with Tableau, with Power BI, how to establish relationships. And once you have this done up properly, when you build charts over here and apply the filters, it will be much easier to understand what is going on. And also when we come to updating your data, as you can see, these are reference tables. So these are always static. But as new data comes in for your fact table, the population numbers will keep on varying. The year will keep on changing. But these are all static data. And one reason we encode it this way is now your main table, your analysis table is much lighter. And at the same time, if you need further details about the country or the age, you can go to their respective reference tables. And this is what we mean by, coming back to my slides, let me just show. This is what we mean by Olap analysis. If you can see my slides, this is the cube-like structure we have done, as you have seen here. And this is again the heart of your analysis. If you mess this up, it doesn't matter, your charts will never come out the way you need it to come out, because the relationships is what defines how the filter works and how your analysis progresses. Okay, so I'm sorry I overshot by about 10 minutes. 10 minutes, right? Yeah. Is there any questions? As far as implementing solutions, ThatWorks does provide the full service to do this kind of analysis, from data integration all the way to dashboard creation, and even deploying your dashboards to a centralized portal, depending on the type of users that are wanting to view this. We do the full end-to-end. We also provide trainings for each of this software. Like today was just a webinar and a very, very high overview of what Power BI is capable of. There's so much more to look at, but we do provide these services. On your side, for now, is there any questions from anyone? Feel free to, if you want to type in the chat or unmute and ask, by all means. Everyone is okay.
Yeah, hi.
Yes.
I just would like to ask, after the end of the session, right? I mean, like after we did all the steps, do we need to save, or is there anything it will be auto saved or something?
So, okay, I will just, my screen is still being shared, right? So let me open up the Power BI again.
All right.
Yep. As you can see here, these are all the tables that are created, right? You can see, right?
No.
Oh, sorry. Let me share my screen. Okay. Yep. You
Okay.
can see now, right?
Yes.
So usually all these tables that you have created will be stored into a database because you have created these new tables. Because we can't, if you store everything inside Power BI, it will slow down its performance. So initially, this is your raw data, correct? From your own system that you are getting, for example.
Okay.
Then as you import the data from your database, you bring it into Power BI, you clean it, and then you will resave this data. We can import back this data into databases. So if I go back to my slides over here, you look at this life cycle, you see this here.
Okay.
So this is your data source. Usually we will use a separate third-party tool to do ETL, but Power BI has the capabilities to do it. So Power BI sits over here. So you will bring in the data from your raw data source, whether it's a CSV, other databases, websites, whatever, clean it, and you must store it in a separate area. And then from there, either you can use Power BI again to do your charts or your analytics. ELT is extract, load, and transform. Here is extract, transform, and load. Both are interchangeably used depending on how the pipeline is going to be executed. So yeah, whatever work I have shown you, as things like the static table, when we go back, the static table will not change. But as new data comes, every month, your data source over here is going to give you new data, updated population reading, annual readings, whatever. So Power BI will run a cycle. We can automate this whole process, even using scheduling technologies or even Windows scheduler. So every month, what we will do is we will trigger the computer to open up Power BI. We'll trigger the computer to open up Power BI and run this entire steps on the new data.
Okay.
It will run the pull sequence to pull new data and rerun all the steps and then resave the data into the warehouse over here. And then after that, the end users who are sitting on the computer side, probably everyone who's in the call today, you guys will be seeing actually just your charts being updated. But you can say under the hood or the engine, this is what was going to be automated to run either by day, by month, depending on how frequency what's the frequency of the data. But the steps, the cleaning steps that has to be set in place and locked is what I have shown you today.
All right. Okay.
Automation is a separate thing. That one is more onto IT side. Your IT people and even our IT people can talk more on that if you actually want to do a full implementation. Yeah, but once this is done, automation is no big deal. It can be done very fast.
Okay. All right. Thank you.
No problem.
Mr. Shankar, I have a question.
Yep.
All right. So previously, when you do the data cleaning under the age group category, right? So we saw we have 0 to 4, and then we have some dates in the column, right?
Yep.
So why earlier the system didn't detect that as an error?
Okay. 1 second. Yeah. Let me just go back to where was I? Over here. You can see, right? The Power BI environment.
Yeah.
Okay. So you were saying earlier there was an error here, right?
From my view, I'm just seeing the add conditional column.
Okay. Okay. So right now, when we are doing the changes here, it will not throw an error until we hit apply. Okay. Earlier, the error came because remember when I did the cleaning step to 1 second. Yeah. Over here, I wanted to pull out the number 4, right? I wanted to pull out the number 4. And how I pull out the number 4 is by saying everything after the dash, pull out the number, correct?
Yeah.
But this 100 initially wasn't a dash, it was a plus sign, remember?
Yeah.
Yeah. So it will straight away show a null value but it won't send an alarm yet. That means if I'm not looking, I will not see this null value. But only when I hit apply, it will say error. And when you diagnose the error, it will say, couldn't transform this number or couldn't extract this number. And then this is where you need to go back and then from here see, okay, I need to remove this step and then undo this step and work. That's why they have this log. Yeah, this log over here. So you can go back and undo certain things. So initially what I should have done is change this to a dash and then run the extractor, because then the extractor will say, okay, there's a dash, take out the 100. And then once the 100 is come out, then the conditional column will work. So if I come to here, so initially I went and do error, I did the conditional column. So it will just do, because right now under transform, when I say, as long as I haven't hit apply, it will do anything I want. It will show the error, but it won't send a warning yet. That means it won't pop up a warning. The moment I hit apply, then only you will know a warning will be triggered. So other than that, if you are not paying attention, you must hit apply and check in between if anything happens or not.
Yeah, right.
Yeah, like for example, I can even say change this to number, but we won't know what we won't know. Wait, let me just come back to the end here. Okay, I say change this to number. So right now you see it turns to error, right? But if your data set is like 10 million rows and you are not paying attention, you won't know this has turned to error until you hit apply. Then you will see something happen.
So is that means every time we apply any change, we do any changes, we have to click the apply button? Is it advisable to do so?
If you intend to check it every time, yes, but usually these cleaning steps are pretty straightforward. That means you will have to make quite a big error to find out that something went wrong. So usually what we do is we go table by table. As I'm creating a table, when I'm done, click apply and then diagnose the issue. Because if you go step by step, it may be confusing also, because sometimes your next step may be able to fix what your previous error was sometimes.
Okay. All right. Thank you.
No problem. Okay, we have a question. Okay, so for real-time analysis, that means the data is a streaming data. So things like the static table, if you when I say all the dimensional tables, you can still set this up because the streaming data won't affect. The streaming data will affect, in this case, the population data because and the year data. These will be fixed regardless of what kind of how frequent the data is being pulled. So in that case, usually when we are building this reference table, there's actually schemas to follow. You can actually Google and check. There's something called as snowflake schema and star schema. So these are the general schemas used when we are designing, when we are doing data modeling. Yeah, when we are doing data modeling, these are the schemas that are used. For real-time data, you need to be careful on what type of software you're using. Power BI is very strong in that, but you need to make sure when you pull the data into Power BI, your hardware, your underlying hardware can store this massive buildup in data, because if data is coming in by the second, then your underlying processors and your data storage must be good. If not, your graphs are going to start hanging and it'll update very slowly. Power BI itself is designed to handle streaming data. This is where we talk about cloud solutions, where we have AWS and Azure. So Azure is a Microsoft cloud provider, and as such, they have integrated Power BI to all their cloud services. So over there, they have very, very strong streaming data storages and processing capability. And Power BI just sits at the end. If you see my slides, Power BI sits at the end. Over here, they have very advanced cloud solutions to keep on streaming the data into Power BI. And the storage also, they have something known as an infinite storage solution, whereby you can store up to more than petabytes of data continuously with no problem. So as far as strategies goes, you can still follow the same principle. As I mentioned, star schema, snowflake schema. I think there's another one, waterfall schema as well. But the main concern for real-time data is if the data is being generated by like from an API, every second you're getting a temperature reading or some rainfall reading, you need to think about your underlying hardware and also your DB. Also, you need to choose an ideal DB. Maybe you need to do a study between, say, Oracle, MariaDB, Microsoft SQL Server. Which one is better accommodated to handling this type of read and write of data that is very frequent? So that's more on the IT infra side rather than the analytics portion. I hope that's clear. Okay, anybody else with questions? Okay, if everyone is clear, by all means, you have our company details. You want to email an inquiry for projects or things like that, or training also we do provide. If not, I hope today's session has been beneficial to everyone. I know I took a bit of a detour instead of showing charts and graphs and whatnot, which is the common thing for BI tools. But I felt this was a very important thing for users to know, because learning the charts is easy, but setting everything up is, I personally, over the past 4 or 5 years, came to realize is not at all an easy thing, regardless of how many projects you do, because that's what changes. The charts are the same. The underlying data source and setup is the one that changes from project to project. Okay, so thank you, everyone. Hope to see you all again, and hope to see you all soon for any collaborations for projects and whatnot.